Hi and welcome. I hope everyone is okay. In this lesson, we will pass the different chapter 3, measures of variation. Firstly, we will discuss about how do we best summarize a set of data. Okay, now we can start. Consider the runs scored by two batters in their past 8 cricket matches, which are given in the following table. We have two batters A and batter B. Now we see the total score, but both batters has have the same score. And if we want to find the mean or average, it is 8 cricket match. So the first one for the first one, the mean is 224 divided by 8. It means 28. It also for the batter B, average is 28. But sometimes the means or the average the same, but they have different separate all scores. Now we will think about this situation when the means are the same. What what will we look at the other measures or datas? Okay. The mean number of runs scored by A and by B is the same, so 28. However, the patterns of the numbers of runs are clearly very different. The numbers for better A are quite consist, whereas the numbers for better B are quite varied. If you look at this table, for the first batter, have consist score 25, 30, 31, 26, 31, and 28, 29, and 20, 24. All scores were nearly each other. But for the if you look at the batter B scores, he he has for example 2, but he has for example 104. He has 0 score, but also he has 70 score. If you look at the only average, this is the situation a bit mistake. Would be become a bit mistake, because their average the same, but the better A, the more better A more consists than better B, uh, because better B are quite varied. Okay. A measure of central tendency alone does not describe or summarize a set of data fully. Although it may tell us the location of the more central values or the most common values, it tells us nothing about how widely separate out of values are. Two sets of data can have the same mean, median, or mode, yet they can be completely different. Okay? A better description a set of data is given by measure of central tendency and a measure of variation. Variation is also as separate or dispersion. Please remember that better B scores have a quality of separate or dispersion, because he has also zero score and 100 for very separate, very dispersion. Okay, now the consistency or lack of it can be indicated by measure of variation, which shows how separate out of a set of data values are. This consistency shows us how separate or out a set of data values are. Three commonly used measures of variation are range. The first one, the range. The second one, as you remember, interquartile range. And the third one, the standard deviation. They are about measures of variation. Okay. Now the range. As you know, the range is numerical difference between the largest and the smallest values in set of data. One advantage of using the range is that easy to calculate. But however, it does not take the more central values into account, but uses only most extreme values. It is often more informative to state the minimum and maximum values rather than the difference between. For example, in a test for which the lowest mark is 6 and the highest mark is 19, the range is 19 minus 6 equals to 13. For group data, we can find a minimum excuse me, minimum and maximum possible range using the lower and upper boundary values of data. For example, to the nearest centimeter, the tallest and shortest pupils in a class are 172 centimeter and 149 centimeter. Find the least and greatest possible range of students. Okay, now they tell us the tallest and shortest pupils class are tallest pupils nearest to the nearest centimeter 172, and so we can say the tallest pupil should be, for example, x greater and accused than 171.5. If the pupil of their height should be 171.5, so to the nearest centimeter becomes 172, and also should be might be 172.5, because, for example, if the pupil height is 171.4, 172.4, we can roll to 172. And for the shortest pupil, shortest pupil, y and 149 should be 148.5, and less than 100 49.5. Please think that this situation, for example, the shortest pupil height is 148.6. You can roll the 149. So we can accept their height, their heights, their heights gap, this situation. So if we want to find the least possible range, we should the tallest pupil height, we can take 171.5, and for the shortest pupil 149.5. So if we can these height, our range our range becomes least. So it should be 171.5 and 149.5. So if I get these value, their values are very near, and if their values gap near, so range the possible range becomes the least, and it should be 0 and 2, then 2, then 0. So the least range, possible range, can be 22, and the greatest possible range, we should take the upper boundary, and we should take the other shortest for the shortest pupil, the lower boundary. So our range is very large. Our range is very becomes very large, and the greatest possible range, 172.5 minus 148.5, and it becomes 0, 4, and 2, and 0. So the greatest possible range becomes 24. Okay, now we have one more example. To the nearest kilogram, the heaviest and lightest pupil in a glass are 70 kilogram and 49 kilogram. Find the least and greatest possible range of the students' weights. So the heaviest pupil, kilogram weight is 70 kilogram. So if we say the name X, it should be less than 70.5, greater and can be greater and equals to 69.5. So if the heaviest pupil weight become this gap, and the nearest kilogram becomes 70, and for the lightest pupil, we can say Y, it should be less than 49.5, greater and equals than 48.5. If we accept this gap, The largest pupil to the nearest kilogram becomes 49. Okay, and if we want to find the least possible range, if we want to range very short, we should take the uh, lower boundary, the other for the other pupil, the upper boundary. So our gap is our gap will become very short. This situation, this process is 69.5 minus 49.5, it becomes 20. If we want to find the greatest possible range, the tallest, the heaviest pupil we should accept 70.5. The lightest pupil weight is we can accept 48.5. So our range is very large, and we can find the greatest possible range, and it means 22. Okay, now the interquartile range and percentiles. The lower quartile, median and upper quartile, as you will recall, divide the values in data set into 4 parts with an equal number of values in each part. These 3 measures are commonly abbreviated by Q1 for the lower quartile, Q2 for the median or middle quartile, Q3 for the upper quartile. And the interquartile range is the numerical difference between the upper quartile and the lower quartile, and gives the range of middle half, 50% of the values. Now we have a data set, so this point is smallest value, this point is the largest value, and Q2 means median, and the lower quartile and the upper quartile. And if we make the subtraction between Q3 and Q1, we can find interquartile range, and the interquartile range, middle half of the values, for example 50%. And if you want to interquartile range, you should make upper quartile minus lower quartile. So Q3, it means Q3 minus Q1. The interquartile range is often preferred to range because it gives a measure of how varied the more central values are. The interquartiles range often preferred or to the range. It is relatively unaffected by extreme values, also called outliers, and can be found even when the exact values of these are not known. We have ungrouped data, and our data values are 2, 4, 6, 8, 9, 9, 10, 13, 29, 32, 36, 48, and 60. We have 12 ordered values, and we want to find interquartile. Also, the first step, we should find the median. If we have 12 ordered values, so we separate the two parts, these values, and 12 divided by 2 and becomes 6. So 2, 4, 6, and the first half here, the second half here. And the first half, for the first half, the for the lower quartile, the middle of these values, we have two value, because we have even value. So we should take both 6 and 8, and we should find 6 and 8 mean. So it means 6 plus 8 divided by 2 becomes 7. It is the lower quartile, or Q1. And the upper quartile, also we have 6 value, so we have even values. So we should get 33 and 36, and we should find these value. We should find the mean of these values. So 33 plus 36 divided by 2, and it becomes 34.5. Okay, now it is the upper quartile, and also name is Q3. And if we want to interquartile, we should find Q3 minus Q1, and it should be 34.5 minus 7, and it becomes 27.5. The other section, we have 15 ordered values. So 15 ordered values: 2, 4, 6, 8, 9, 10, 12, and 13, 29, 33, 36, 40, 46, 48, and 56, and 64. And the first step, we should find the middle of these data and ordered values. So 15 values, the middle of the 15 values, 15 plus 1 divided by 2, and eighth value. So 2, 6, 2, 4, 6, 8. The median is 13, and the median separate two parts of our data, or our values. And for the first part, for the first half, the middle of the value, the middle of this part, 8, because we have 8, the left of the 8 we have 3 value, the right of the 8 we have 3 value. So 8, the middle of this part, so it is the lower quartile, or Q1. And for the second part, we have 7 value, and the middle of the 7 value, the fourth value, 1, 2, 3, 4. It is fourth value, and it means the upper quartile are the and the other name Q3, so it becomes 40. And if you want to interquartile, means 40 minus 8, it becomes 32. Okay, and we have one more example about stem and leaf diagram. We have 13 grouped values, so we want to find interquartile. 13 group values, the median is we should find 13 plus 1 divided by 2, because we have odd grouped values. So the seventh value is median. And 1, 2, 3, 4, 5, 6, 7. This is the median. The median is 136, and we have the left of the median. We have 2, 4, 6 value. So we have 6 value. If we want to the lower quartile, we should find the middle of the 6 value. But 6 is even, so we should find 2 value, which is the middle of the first part. Okay, and we should take these values, because the both value the middle of the first part. So for the lower quartile means 124 plus 126 divided by 2, it becomes 125. For the upper quartile, and also we have 6 value, which the right of the median. So we should find the middle of the second part, but we have 2 values, the middle of the second part. So they are 9 and 2, 139 and 142, because 139, the left of the 139, we have 2 value. The right of the 142, we have 2 value. So the both value the middle of the second part, or right of the median. Okay, now if you want to find the upper quartile Q3, we should find mean these both values. So 139 plus 142 divided by 2, it becomes 140.5. And we want to interquartile, and interquartile means Q3 minus Q1, and it means 140.5 minus 125, it becomes 15.5. Okay, Okay, now in this activity, we have an activity. In this activity, you will investigate the value of the median in relation to the smallest and largest value in a set of data, and also in relation to the lower and upper quartiles. For each ordered set of data A to D, write down these five values: the smallest value, the lower quartile, the median, the upper quartile, and the largest value. We have four set grouped. It may be useful to mark the five values for each data set on a number line. Okay, now I want to draw a number line for each set data. So for the first one, and for the second one, for the third one, and I have no area for, okay, the first one. Okay, now firstly, the smallest value is 2 for the set of the A, 2, and the greatest, the largest value is 22, and the median, the median is 11, and excuse me, the median is 11, and the lower quartile is 2, the lower quartile is 2, the upper quartile is 20, 21. But if I put the second pool, it would be wrongly, because we have also 2, so we can use these two, both lower, both smallest value and the lower quartile. Okay, now the second one, the smallest value 6, the largest value 20, and we have 3, 4, 5, 6, 7, 8. So the median is 12, and the lower quartile is 6, the upper quartile is 19. Okay, and the lower value 9, the upper value 49, and the median is 30, and the lower quartile is 9 plus 15 divided by 2, so 12, and the upper quartile is 35 plus 49 divided by 2, so 38, and for the set D, the smallest value, the largest value, we have 4, 6, 8, 9 data, so 11 is median, and 7 plus 9 divided by 2, our lower quartile, it means 8. 12 plus 16 divided by 2, the upper quartile, it means 14. Okay, and use the result to decide which of the following statements are always, sometimes, or never true. Okay, now we have data set, and we decide these situation, these sentences, and the median is midway between smallest and largest value. Okay, now we should find this situation. The median midway between smallest and largest value means, for example, the first one, their range is 9, and their range is 11, their range is 6, their range is 8. So the median is midway between smallest and largest value. So this is the not the same, because their range is also different. The median is the second one. The median is midway between lower and upper quartiles. Lower and upper quartiles. Okay, now the median 11, the lower quartile 2, the upper quartile 21, and their gap is 9, their gap is 10, and the median 12, their gap, for example, the lower quartile 6, the upper quartile 19. So their gap is 7 and 6 and 7. Their gap 18, and their gap 8. Their gap 3, and their gap 3. For the set D, the median midway between lower and upper quartile. So we can say sometimes this sentence. The interquartile range is equal to exactly half of the range. Okay, the interquartile for the set interquartile, 21 minus 2, so interquartile 19 equal exactly half of the range. Our range 22 minus 2, 20. Half of the range 10. So the second data, our interquartile 19 minus 6, so 13, and our range 20 minus 6, 14, the half of the range 7, and interquartile means 38 minus 12, it becomes 26, and our range 49 minus 9, half of the range 20, and the interquartile means this situation 6, and the range 12, the half of the range 6, and we can say the same this situation, the last set. So we can say sometimes say the third situation. And Q3 minus Q2 greatest than Q2 minus Q1. Q3 minus Q2 for the first data A, 10, and Q2 minus Q1 9, and this is true. For the second, Q3 minus Q2 7, Q2 minus Q1 6, this is true. Q3 minus Q2 8, Q2 minus Q1 18, this is not true. And Q3 minus Q2 3, Q2 minus Q1 3, and this is not true. And we can also this situation sometimes true. Okay. Now in this lesson we have no time. Have a nice lesson. Have a nice weekend.